Okay, for the last part of chapter 5, we're going to talk only about one specific type of model in mathematics. This one's called an exponential growth model. So I'd like to give you the basic introduction to an exponential growth model. It would look something in the lines of this, or y equals a e to the bx. Now this should look familiar to you, at least the form of this should look familiar to you. Does it look like anything we've done before?
Yes.
What's it look like?
A to the x.
PERT. Very good. Looks like that PERT formula. A equals PE to the RT, right? Okay. So let's talk about what all these are, okay? The A part, that's your initial amount.
Just the A.
Yeah, just the A part, right? E is this this number that we've been using. It was approximately 2.71, that natural number E. So that's sort of your base, okay? Our initial amount, we have our base, all right? The B part, this is our growth factor. Our growth factor, assuming that B is greater than 1. Or, sorry, greater than 0, excuse me. Being greater than 0. If it's less than 0, then you have a decay. You have a growth decay factor. And the X part here. No more ducks. It is. Okay. All right, back to our growth factor, you guys. A is our initial amount. E is this natural base that we've been working with. B is a growth factor if B is greater than 0. X and Y, the X part is our input. So we're going to input these. Okay. And then the Y part is our output. Okay, so we kind of have the basic set. Yes, sir, Grant. What's up, buddy? So here's a picture of these fruit flies that I was talking about that ended up in my kitchen, all right? And these grow at an exponential growth rate. So here's what I'm going to do. I'm going to give you some data. This is the same box, all right? So I'm going to give you some data. So after 2 days, okay, I'm going to write this down. After 2 days, there was about 100 flies flying around the kitchen. Okay, 2 days, 100 flies. Okay, after 4 days, there was 300 flies. Okay, so the question that I have for you is, after 5 days, how many flies? Right, so what I want you to do is I want you to write your guess down. I want you to take a guess first, right? Guess how many flies. Now, this is not linear. I'm telling you it's not linear. I'm telling you that it follows this mathematical growth formula. So take a guess as to what you think it is right now. Okay, good. So we have some guesses here. We have a range from 400 all the way up to 1,000. So we have quite a range there. All right, so we're going to do some mathematics here. We're actually trying to pinpoint how many flies roughly there would be after 5 days of doing this. So here's what we know. So let's follow this part together. We're going to start with this. We're going to start with y equals a e to the b. And I'm going to change x to t. Why would I change x to t? Because the input is time. Okay, the input is time. Very good, right? So I have two scenarios here. Okay, the input is time. Y, the output is number of flies. So the first one that I knew was this. I had 100 flies at an initial amount, which I don't know. E times 2b. That make sense? So 2 days, right? Time of 2 days gave me 100 flies. Now the other piece of information I know is this, that there were 300 flies, initial amount, I don't know, E, I don't know, after 4 days, so 4b. So ladies and gentlemen, what we have here is a system of equations. What I mean by that is we have two different equations, and we have two different unknowns, namely the A, the initial amount, and B, this growth factor. All we know is that this growth factor needs to be greater than 0 because it's a growth factor. So what do we do? All right, well, what we're going to do is we're going to solve for A in the first problem over here and then substitute it in the second. Pretty cool stuff. So let's solve this equation on the left-hand side for A. What would I do?
Put 2b in front.
Or divide by what?
Divide by a.
E to the 2b. Divide by E to the 2b. So A is equal to 100 divided by E to the 2b. You guys cool with that part? Good. Now I'm going to take this information. Look where I'm going to put it. I'm going to put it right there. Follow that arrow all the way over. I'm going to put that information right there. So moving right along here, here's what we get. I'm going to change colors on you to make it more important and more fun. So I'm going to get 300 is equal to 100 over e to the 2b multiplied by e to the 4b. Okay. Yeah? Yeah. Oh, okay. Now, here's what we have. We have 300, I'll move over here. 300 equals 100 e to the 4b divided by e to the 2b. Anybody see any nice algebra that happens there?
You can
cancel the e to the 2b.
Yeah, if I have e to the 4b divided by e to the 2b, then a grand total of
100 e to the 2.
Yeah, very good. Very good. I have 300 equals 100 e to the 2b because I would subtract their exponents. 4b minus 2b is 2b.
Divide by 100.
Very good. You're on board. We're going to divide by 100. Leave me with this. 3 is now equal to e to the 2b. Hey, it's a good thing we know something about logarithms. Yeah, we're going to take the natural log of both sides. So the natural log of 3 is equal to 2b. Right? Everybody cool with that part?
Yeah.
Good. I want b, don't I?
Divide by 2.
We're going to divide by 2. We're going to divide by 2. So that means that b is approximately, can you guys tell me what that is? The natural log of 3 divided by 2? Everybody said, what was it? 0.5.
5. 49.
0.549? Yeah. Okay. That is our growth rate. Okay, good. What do we need now? Now we need the initial amount, right? So we could substitute this back into, check this out, right, a lot of substituting right here for this b right there. See it? So that means that a is equal to 100 divided by e to the 2 times 0.549. Man. Okay, guys, help me out. What is a approximately? Nelson's got 33.35. Can we back him up there, everybody? Hello. Anybody? Yeah? Thank you. Theo backs it up. Okay, good. So we had about 33 whole flies to start with. We have a growth rate. So now we can finally go back and say, okay, y is now equal to my a amount, which is 33.35, times e to the b amount, which was 0.549 times the value of t, right? So we found the initial amount and the growth rate. Now, the question was, if you remember, what was the question? The question was, how many after 5 days? And we have a couple of guesses here between 400 and 1,000. I'm sure one of those has to be pretty close to it, right? Okay, so what do? We substitute a value of t equals what? Yeah, 33.35e to the 0.549 multiplied by time of 5 days. This will give us flies. So y is approximately, can you figure out how many flies are going to be there? Yes. We calculated to be approximately 520 flies. Does that make sense? Does that fall within our guessable range? It sure does. It falls. And look at this person. Was that you, Grant? Grant guessed 550. That was pretty darn close. Nice job, Grant. Very good. Okay, here's my follow-up question for you guys. How long would it take to have more than 1,500 flies be present? Okay, so we know that after 5 days, there was 520 flies. So how long until you have more than 1,500 flies? Discuss with your group mates.